Hey, welcome to another adventure in old code. Well, I hope you're doing good today. It's about 1,000,003 degrees outside, and I'm melting. So, it's a good enough time as any to do an adventure in old code. Today we are going to look at something called Pool. But now I can't remember where it is. Shoot, it must have been... I just assumed it was my program. Pool. Let's do this. Okay, so yes, indeed, this is my program, and I can tell because of the up and down buttons. I'm using the arrow keys. My brother did not do this. And again, there's some ambiguity over who did this because this is in the Quick Basic folder. So, hey, this looks good. Let's see what happens. I remember this. Okay. So the red thing on the left there. Huh? Oh wow, that is going to be some funky stuff. Why did that not... Why isn't that working? I can't... I press up and I get this illegal function call. I press down and I get the illegal function call. And I press space and I shoot, but I can't... Well, that sucks. Okay. Well, what is my print angle string? The string of the value of the angle plus 5. Oh my goodness. You know what? I'm going to actually probably have to do this. We've seen this in another program. I'll bet DOSBox doesn't... Let's try this, and then we can go over why this works. DOSBox, you are the death of me. Okay, we'll go over what's going on after. So anyway, this little arrow thing, I can move up and down, and then I hit space to actually shoot. And I think the goal is to hit the dot, the brown circle. So, oh, look at that. So I'm trying to bounce... Wow, I'm doing actually pretty darn good. Oh, no. I could just go straight. I don't have any score. It looks like I get a new configuration every time I either miss or get it. Oh, I did get it if you see. Let's I'm sure I'm doing... That's it. This entire program is just this one subroutine plus an initial subroutine. I don't actually see a slowdown. Okay, let's put in a little bit of a slowdown here. Yes, okay. That is more like it. See, so I got it. Oh, and I missed it. Is it going to bounce? It is going to bounce. Now, it doesn't bounce truly against that barrier. Okay. It goes up and down, and then, oh, it kind of did that one. Oh, come on. You could. So I remember, so in school I was learning that when a particle bounces off of a wall, it bounces off at the same angle that it hit if the wall is right. It doesn't matter what angle the wall is, but if I hit this wall straight on, this is going to come straight back at me. This is going to come straight back at me, and that's not physically correct. Oh, I made it through there. Yep. So anyhow, I knew of this deficiency. I remember that deficiency. Oh, see, that one did. Oh, and I did it too. Okay. And it bounces back. Okay, well, that's cool. We are going to have to dive into this because this is fairly sophisticated. We're going to have to... Oh. Uh-oh. Uh-oh. Oh, no, it broke out. Okay. This is fairly sophisticated. Some trigonometry is going on here, and so we'll have to talk about it. But just 1 second. I'll have to do this in a few minutes. All right. Well, let's have a look at this. This is awesome. This is... Yeah, it does not follow the laws of physics very well at all. Okay, so this is a very small program. We have one subroutine initial. We have our up and down keys, L string and angle string, XFAC, YFAC, X and Y, and a random number generator in screen 12. All right. All right, so up and down, again, our dual character codes, clearing the screen. So this is the outer game loop. Okay, so we're going to go to this initial subroutine. Now, what do we do here? So angle string equals 0. Line, we draw a line from 0, 0 to 639, 479, which is a white box around the whole screen. We saw that. And then we're going to do something 3 times. Now this is going to draw 3 random white lines somewhere in the screen. So the way we're going to do that is we're going to take B, C, E, and F, and they're all going to be random. So B will... We draw... Oh, right. Okay, so we're going to... We draw a line from BC to FE, and the line from B plus 1 to C, and F. What? All right, regardless. B and C and F and E. Why? Why are those the names of your X and Y values? The first one's in alphabetical order, BC. The next one is not in alphabetical order. It's in reverse alphabetical order. Woohoo. Okay, so we're going to draw a line. Okay, so the first random coordinate is going to be randomly between 201 to 600. And somewhere in the Y direction. The y coordinate can be anything basically on the screen. So we're making sure that the horizontal position of the line doesn't start too close to your to the left side. We're just making sure there's a 200 pixel buffer on the left side, so that when you shoot something, you have space in front of your pool cue. Okay. Okay, that's fine. Okay, and then we're going to draw a line. And then we're going to draw another line, and it's going to be the same coordinates except just shifted to the right once. So I think what this draws is a thick line, not just a thin line. So let's have a look at that. These lines are a certain thickness. And now I'm going to take off. We're not going to draw this one. Comment that out. And so yeah, these lines are okay. And that's why okay, we'll get back to why I made them thick. So that's the thin version. You can see they're thin. And then this is the thick version, which we've seen. Yeah, that's the thick version. So there's a very important reason why I did that. And we'll go over it when we get to it. So we draw the random lines in the screen, and then we're going to draw the circle, which is the brown circle, the goal that we're trying to get to. It's always in the same place, 500, 240. It's 20 pixel radius and color 14, that's the yellow outer circle. And then we paint it in color 6, which is the brown. So that's fine. Then we're going to p-set 1, 240. So that's way at the left side of the screen in the middle, which is our red pool cue. And L string, okay, that's very curious. Ha, awesome. Okay, so L string is the string representation of what we do to draw the pool cue. R20, which means draw to the right 20. We're going to use this L string in a draw command. That's perfect, which we do right next. So draw. Now we've seen draw. We've seen up, down, left, right, E, F, G, and H. This is a C and a T, A. So this is something totally different. Let's go to the help file. So there's so many options to the draw command. We are using the C. So change drawing foreground color. So C4 just means color 4, which is red. So that's fine. And the TA, we want to find the TA. TA, tan, right on. So we can rotate from 0 to 360 degrees. Okay, so when we rotate something, okay, yeah, that's curious. We rotate the coordinate system of the draw command. So what that means is regularly you go right 20, it goes immediately, visibly to the right 20 pixels. But if we first change the angle, drawing right in the draw command actually draws at that new angle. So that angle takes the entire coordinate system, which is your standard coordinate system at the beginning, and it rotates everything. So all of your commands now follow this new angle. And so this angle starts off at 0. So that's the normal default angle. And so what this draw command is saying, C4, color 4, TA plus your angle, which is 0, and then plus L. So this is actually equivalent to C4, TA 0, and then L was R20. And then what's going to happen Yeah, is that's going to... Well, we'll get to it. Anyway, that's what it is at the beginning. So rather than give it a direct string, I'm building it up with these variables. Now, xfac and yfac are always the speed of my pellet, my ball, whatever you want to call it, in all of my games. So this is how fast the thing is moving in the x direction. And it's 2 times the cos of the angle times pi over 180. Awesome. Yeah, 2 cos A times pi over 180. Now the pi over 180. So the curious thing here, and we're going to get into some trigonometry, but the funky thing is the draw command takes, and I don't understand why, but the tan angle here is in degrees. Okay. But the trigonometric functions are in radians. So why wouldn't they have the tan command in the draw statement be radians is beyond me. So I had to convert it. And the way you convert it is you multiply by pi divided by 180. Because 180 degrees equals pi radians. Now, why am I going 2 times the cos A, and yfac is 2 times the sine of the angle? Now I have to figure out what was going on in my 18-year-old brain. All right, folks, I went and recorded a terrible explanation of what was going on. So we're going to try and give this a redo. Why exactly am I going xfac equals 2 times the cosine of a value of an angle times 3.14 divided by 180? I may have already explained that the 3.14 divided by 180, we are taking radians, we are taking degrees and we are converting it into radians because the cosine and the sine functions require radians. Now, the question is, why doesn't the draw command take radians then as well? And the answer is that none of the things in the draw command, none of the moves, none of the all the values, all the numbers, and you can have a whole bunch of them. We can have a quick look at that. Moving up to the left, filling in closed shapes with colors, changing the color of what you're drawing, increasing the size, rotating. The reason it's in degrees and not radians is because all of these numbers have to be integers. You cannot have decimal numbers inside of a draw statement. So that is why they use degrees, because with degrees, at least you can have 360 different values. If they used radians, all you could get is 1, 2, 3, 4, 5, 6, which that doesn't give you much precision at all. So that's why we have to convert the degrees of our angle into radians so the cos and the sine can deal with it. Now, how do you get your paddle? You break it up into the components, your vertical component and your horizontal component, and this is where you can thank your grade 9 math teacher. I made this little program after I did such an awful job the first time. Hopefully this will be better for us. Okay, so what we have is a triangle, a right triangle. The red line is 20 units long. It denotes your paddle in this game, but it's just the hypotenuse of a right triangle, and that is our arbitrary angle that I started us at 31 degrees. So to get the length of the purple line, your horizontal component, we have to remember that the cosine of 31 degrees is equal to the adjacent the purple line, over the hypotenuse, which is 20. So rearranging a bit, we can multiply both sides by 20, and we get 20 times the cosine of 31 degrees. And what does that equal to? That is equal to 17.14617. Now, similarly, the sine is the opposite over the adjacent, over the hypotenuse. And so that can also be rearranged to be 20 times the sine of 31, which gives us the green component, 10.29. So the upshot of all this, if I pressed space now to fire my ball, I will be moving 17 pixels every time through the loop to the right and 10 pixels up. And that is going to more or less be 20 units on the 31 degree line. And so, I mean, we can have a little bit of fun with this as I move my paddle closer to the horizontal. You can see my angle is decreasing. The hypotenuse, the red line, is staying the same length, but the components of that line and that angle are very different. So you can see if I fire at like 3 degrees off of the horizontal, I'm basically going, all of my motion is to the right. Every time through the loop, I'm going to move up 1 pixel. And, you know, similarly, we can go all the way up. And obviously, now most of the values are on the vertical. So that is what's happening. That's why we're doing that. Never, ever, ever did I ever look at my math teacher and say, why do we even need to learn this? I'll tell you why you need to learn it, so you can make you basic pool games. All right, I think I rest my case. So that is why we were doing it. Now, the two, as we'll see later on in this video that I realized later on, was meaningless. It's really 20 is what we're trying to do, because our pool cue was 20 pixels long. So that being said, we can go back to the pool and finish off this video. Let's get back there while I hand it off to my previous self. So previous self, I think you were here. Take it away. That didn't go very smoothly. Okay, still going on to the initial. So that is what the x-fac and the y-fac is at the beginning. Now at the beginning, angle is 0. So the cosine of 0 is 1, and the sine of 0 is 0. So y-fac will be 0 and x-fac is 1. When you shoot it, it goes straight to the right without going up or down. So that is that. Yay for the trigonometry. Okay, so that sort of initializes it. Now we're going to start second game loop. Second loop. Done equals 0. Of course, we haven't finished yet. Wait for a key press. Okay, if we pressed up, then what we're going to do is we're going to color 0 left 20. So remember, the draw command always starts at drawing at the last point in which it stopped. So that's why we don't actually have to p-set here, because the last thing we drew was a right 20 to draw the paddle, the cue. So all I have to do is change the color to black and draw left 20 to erase it. Okay, and once I do that, now I'm back at the origin point and I'm ready to draw my next red line. So I'm going to, my angle is going, so angle string is a string. What I need to do is I need to add 5 to it. But in order to do that, I have to convert it into a number, add 5 to it, and then convert it back into a string. So one thing I could have done was just have angle not be a string, just be a number. And when I wanted to put it in the draw command, then convert it to a string. But I decided, no, it's just going to be a string. So I have to do this double conversion here. So basically, when you press up, the angle increases by 5. And then this does the exact same thing. C4, switch to this new angle, and draw L string, which was set as R20, and it stays R20 forever. So we erase the line, change the angle, draw the line. That's what we're doing. Down does the same thing, except we subtract 5. So I wonder if I can actually... Oh, right. Okay, so here's the thing. Because in our... We've realized that DOSBox likes to take actual integer values 4, 5, 6 and turn them into 3.9999999 and all that kind of funky stuff. You can't actually have decimal numbers in a draw statement. That's why it's stopping here, because it's like, you can't have an angle of 4.99999. That can't happen. So that's why I was doing this cint earlier. Cint just it rounds it to the nearest integer. So this is not something I would have had to do when I was running on real hardware. Okay, so my curiosity, can I go all the way backwards? I can. Well, I guess I got too big. That's why trigonometry is cool. It's a circle. It will go into a circle. Oh, there we go. Guess you can only do so many angles. Okay, yeah. Okay, so that's that. Now if we hit space, this is where we do our shooting, and this is basically the whole thing. There's not much to it. So we take our xfac and we say it's 1 times the cosine of the value of the angle times pi over 180. Okay, because we're shooting, we need to figure out the new xfac and yfac, because the angle would have changed. Yeah, okay, that's fine. So we get the xfac. The yfac is minus. And I would have done that because the sine values, it's probably flipped. Sine is negative when you're in the... Okay, yeah, so sine is negative when you're in the bottom right quadrant. And so I had to negate it because a positive y value in trigonometry means you're going up, but in the QBasic screen 12, bigger values of y go down. That's why I had to negate it there. Okay, x equals 0 plus 20 times the yfac, xfac. Y equals 240 plus 20 times yfac. This is just putting the starting position of the ball at the very end of the pool cue. Okay, now we're going to loop around. Yeah, so can I explain this any more? Well, the xfac is what you would do for every, how far you would go in the x direction for every 1 unit of length for your red line. But our red line was 20 pixels. And so that's why I'm moving over 20 times xfac and 20 times yfac. Okay. Now the way I check for bouncing off walls, I have to figure out when my ball collides with a wall. And I use the point command. These lines that I drew are not stored in memory anywhere, and so I couldn't figure it out algebraically with the representation of the line in memory. I just simply had to say, hey, I want to draw the ball at this pixel. Look at that pixel first. Is it white? If it's white, then the so if where I want to draw it is white, then what I'm going to do, check again. If it's less than 1, x plus xfac is less than 1. That means if I'm off the screen, then done equals 1. Otherwise, negate xfac. So start traveling backwards on the horizontal. This is curious. Why does this have a check here? What happens if I just get rid of it? I think I hit the... Oh, that's why. So that's cool. Whoa. So that check makes it not bounce off. Yeah. That's right. That's why I drew the white box around the screen so that the ball would bounce off the wall. But I didn't want to bounce off the left edge. And so I do this check here. I could have just erased the wall, but I do this check. Are you off the screen? Then you're done. Okay. Okay, same thing with the Y. If we hit white, then negate. And so this is why it bounces off and comes right back, because it's negating both xfac and yfac. So it hits, whatever it hits, it just starts traveling completely backwards. And it's not respecting the angle at which it bounces off a wall. So if the wall is not a vertical wall or a horizontal wall, it does funky things. Okay, then we p-set xy 1, which is blue, so we draw our ball. Oh no, that's the trail, the ball trail. It's where the ball was. Then we add xfac and yfac. We update the position. And then we're going to check, okay, is the new position brown? Which means did we get into our goal? If so, then done equals 1. Okay, and then we're going to put the ball, which will be yellow, 10. What color was 10? What color was that? Oh yeah, it's bright green. Okay, bright green. I used to have them all memorized. Okay, draw our bright green ball. Loop until we're done. Then we're done our checking for what we hit, and then we loop until done again, and then we just keep looping, which means we never leave. So wow, that was kind of funky. The only thing I'm curious about is this value. Why this was 2 and not 1. What happens if I change that? I don't think it's ever used that 2 times. I must have... Here's what I think. Okay, I'm gonna... I'm going to put this break in here one more time. We'll make it 200 this time. So the decision to do 2 times here, I don't think I ever used it because first it gets initialized, but when I actually hit space, I calculate it again using 1. So if I were to have done 2, this would have just moved twice as fast, which you can see puts me through walls. Ah, yes, and that is why... Ugh, that's gross. And that's why I made the lines bold, because... Okay, let's get this back. Because the way we check for a collision is look at where we were going to draw the ball. Is it white? Then a collision happens. But you'll notice yeah, so here's the thing. The cosine of an angle is always between 1 and -1. The sine of an angle is between 1 and -1. So the x-fac and y-facs will at most be 1. So the ball is never moving more than 1 pixel away. But it could be 1 pixel diagonally. And if you'll notice, let's go back to initial here and not draw our thick line. If I were to get a line perfectly, no, that's not going to work. That's a pretty good line. Can I get through it? Yes. See, so it did bounce through it. And that's because the way the computer draws the line, it's not a nice smooth line. It's more like this. And so my ball hit that very edge there where the break was. I have awesome terminology right now. And it made it actually through the line because it went to the next diagonal pixel and there was nothing there. So that's why I made the thick lines. And that's why I probably thought that I wanted to start it at speed 2, but speed 1 was necessary because otherwise I'd be jumping over lines. Anyway, okay, that's Pool. I'm running out of battery here, so I should quit this for now. Thanks for joining me in this adventure in old code. Have a nice day, and we will see you next time.